Hi everyone, my name is Avery Hagleitner, and as Lynn mentioned, Tugfeast is also in the room out there in Ottawa. We're going to give you a preview of a hands-on lab that we're going to be presenting in Vegas, October 28th and 30th at the Insight conference. This is a revamped version of the hands-on lab that we gave last year, and I think those recordings are out and is that on YouTube. I know this is kind of said it's a hands-on lab, but I'm not expecting you guys to be following along at home, going through instructions or have anything set up. I will be going through a walkthrough of the instructions and doing a little show and tell as we go through it. So I know we have just a little shy of 3 hours for this session. I'm going to probably take a break halfway through. It'll probably be after the second lab module. Okay? Based off of the foundation you had from last year's lab, where we went through the typical application lifecycle of working with dynamic cubes, and where we went through modeling, deploying, administering, optimizing, securing, and combining cubes into a virtual cube. So this year's lab, it's taking it to the next level. We're going to go through a bunch of the new features that have been added since last year, as well as popular features that customers have been using or asking about, and we wanted to showcase them here. For your reference, last year's lab, if you haven't had a chance to take a look at it yet, it might be a good, little homework assignment to take a look. They're out on YouTube. Here's a little shortened URL. Part 1, which covers modeling, deploying, administering. It's out at ibm.biz, Dynamic Cubes Lab number 1. And Part 2, for optimizing, securing, and combining cubes, out at ibm.biz, Dynamic Cubes Lab number 2. All right, so for today, I'm going to go through a quick highlight of all the new features of, things that are what's new. It's going to be pretty much an overlap a little bit of what Dave had already presented earlier this morning. So it's just going to be a quick list. You'll see, gosh, wow, we really did a lot in the last year in terms of new features and functionality. I'll cover a review of the lab scenario, as well as each of the 5 different lab modules. Now, in the interest of time, as well as making sure that I have enough focus on the lab modules, I'm only going to actually go through a subset of these today. I'll do the first 3 because I think these are the most popular or most interesting parts of the lab. So I'll cover reducing memory footprint and building an efficient cube, maximizing reuse and simplifying report authoring, as well as optimizing a cube's performance. And depending on how we are with time, and maybe if there's interest, possibly we'll take a look at scheduling a follow-up session about enabling reporting analytics for historical and planned data trends in one place, as well as incrementally updating data caches with less cube maintenance. Okay? All right. Let's jump into it. So you can see this is a long list of some of the new things that have come out of Dynamic Cubes and Cognos BI since last time. And these are just the quick bullet points, little highlights. We've made tons of memory utilization improvements, including being able to share dimensions, share parts of the member cache, which is helps to reduce memory footprint a lot. There's a memory hardware sizing calculator that's now available as part of Cube Designer. Relative time. We finished out all the other relative time extensions, such as showing future periods, custom numbers for single period, period to date, as well as the end period running total. We have name set support. One thing that we're not going to cover in this lab, but pretty cool, is the ability to publish a package containing multiple cubes. So you can have one package that you're doing your reporting or dashboarding in and reference multiple or different cubes. We've released a DC admin command line administration tool that's available on both Windows and Unix flavors. So basically, anything you can do in the admin console via the UI, you can also do via this command line tool. DQA, or Dynamic Query Analyzer, as well as the Aggregate Advisor that you run out of DQA, has had tons of improvements to improve its recommendations and its heuristics. We have support for user-defined in-memory aggregates. I'll show you that later in this lab, as well as automatic optimization of in-memory aggregates. We're not going to cover that in this lab today, but this is some awesome stuff where you can enable a cube to have the aggregate advisor run automatically in the background and recommend a few in-memory aggregates based off of the latest query workload. We have support for incremental updates of cube data. We get a lot of questions about, hey, I have new fact data, what do I need to do to refresh the caches, and so forth. With this new feature, you can actually update the caches live in the cube without having to stop and restart it. And I think Dave mentioned this in the session earlier today, something that's really awesome. It's not just for dynamic cubes, but it's for the whole query service, dynamic query server. We have improved server stability. So basically, in the past, you know, if you had opened it up to more users or users that don't run the best queries, maybe something really low at the lowest levels of granularity, the server, the query service JVM could run out of memory. Now with this improved service stability feature, we now have resource monitoring. We now monitor the memory usage in the server, and when it gets to a certain threshold, I believe it's 90%, we will go into like lockdown mode and start canceling queries based on a certain rank of the most expensive queries, canceling them first to get the memory usage down to a normal level, and then opening it up again. So this will keep our cubes and our servers up and running much longer, and hopefully, you know, I'll try to avoid that the hideous out-of-memory errors that we used to get in the past. Okay, so just want to give you a preview of our lab scenario. So I'm assuming everyone is familiar with last year's lab. If you haven't, let's just pretend we did. So you've implemented your recent historic virtual cube scenario. So you've experienced the whole typical life cycle of developing a dynamic cubes application, and now you want to do a few things, right? So you might want to ensure your efficient use of resources. You have some memory, you have some hardware. You want to make sure you're making the most of what you have. Maybe next you want to maximize report productivity. You have a bunch of report users, report writers, and you want to make sure that they're as efficient as possible. You might also want to optimize performance, which is part and parcel of what the Dynamic Cubes is all about, right? Very fast, high performance queries against your very large data warehouses. And as part of that whole life cycle, there's maintenance. And so you might also want to update your data with less maintenance. As I mentioned, we probably won't get the chance to get to that last bullet today. But again, if there's interest, we will look into scheduling a follow-up session on that. Okay. All right, so just a quick little refresher on the Dynamic Cube lifecycle. This slide should look very familiar to you. We're starting out with the data warehouse here, and we really emphasize having your data in a star or snowflake schema because that is the best for performance. So from your data warehouse, you will still use Cognos Cube Designer to do your modeling of the cubes, as well as publishing those cube models to the content manager, to the content store. From there, you still use Cognos Administration Portal to deploy your cubes to a dynamic query server, as well as managing the lifecycle of that cube, starting it, stopping it, refreshing caches, and so forth. Once you start a cube, it lives in the dynamic cube server, ready for users to start querying against it. Your users would then go into the studios, Report Studio, Cognos Workspace Advanced, what have you, and do the reporting and analytics against that cube. And optionally, you can choose to capture that workload information or other bits of information in logs that live on the server side. And to round out the life cycle, after a few runs, some representative workloads, some time has gone by, you might want to go ahead and optimize your cube with aggregates and so forth by running the aggregate advisor within Dynamic Query Analyzer. That's just a quick recap again of the Dynamic Cube lifecycle. Here is the schema we'll be using or have been using in the past and will continue to use in this year's lab as well. It's a simple star, actually a snowflake on the product dimension schema of historic sales. Historic sales is the fact table in the middle, and we have 5 dimensions all around. We have product that's snowflaked out with 3 hierarchies. We have a time dimension, promotions, order method, as well as a retailer dimension. Okay, and so if you remember from last time, we also have a recent sales cube, which is basically the same thing except it has a different fact table in the middle. It's called recent sales. All right. Let's get into the lab modules. We'll start with the first one, reducing memory footprint and building an efficient cube. What I will do is I will introduce the different tasks as part of these lab modules, and then I'll change gears, go into the VM, and go through those steps. So there are 3 parts to this lab module of reducing memory footprint and building an efficient cube. They are, we're going to talk about shared dimensions. We're going to talk about dimension filters, as well as the estimating hardware requirements. So let's jump into a few of these slides. We'll do an introduction, and then we'll go into the lab demo. Okay, so this should look somewhat familiar to most folks. This is our usual slide where we talk about all the extensive caching that we have here. And as you might remember, when we start up a dynamic cube, the first thing that gets loaded is the member cache. So this is all the metadata, dimension, and member information is loaded up into memory, into the member cache. Once the member cache is loaded, the cube is running, and it's open for business, ready for queries to start running against it. After that is the aggregate cache. If you have in-memory aggregates, they get loaded in parallel right after the member cache is completed loading, and as queries start coming in, we'll start populating things like the query data cache, the expression cache, as well as the result set cache. So that's all fine, well and good, as you have an existing cube here. New in, I guess it came out in 10.2.1 Fixed-Pack 3, dimension members can now be shared between your dynamic cubes and your virtual cubes that reside on the same server. And what this helps with is it helps to reduce the overall memory footprint. So if your project contains any dimensions that are referenced by 1 or more cubes, you can share member cache. So this means that each shared dimension is only published once in the caches, regardless of how many cubes reference it. And so for example, if I were to start up a second cube that does share some of the member cache, it's really fast. It's super fast. All it does is reference the cache that had been created by the first cube that gone through here. So creating that shared member cache improves performance because it reduces the amount of memory needed for the cubes after they're started and published. And although this picture kind of shows like you have to share all your dimensions, that's not true. You can share just a subset of your dimensions. This picture is just the best case scenario where you're sharing all your dimensions, but really you can share 1 to a few of your dimensions in your cubes, and it actually especially helps with your very large common ones like product or time. So in the lab, which I'll show you in a little bit, we will look at the historic sales and recent sales cubes from last year's hands-on lab, because those 2 cubes had the exact same dimensions and they're very kind of perfect candidates to be shared. Okay, so that's the shared member cache topic. And then the rest of this animation here on this slide is just showing that everything else is the same. All the other caches, each cube has its own aggregate cache, data cache, expression cache, result set cache. The only thing really shared here is the member cache. Okay? All right, so our next feature that we'll go through is dimension filters. So dimension filters allow you, the modeler, to subset your dimension or subset the available fact rows. So really, when you're creating a new dynamic cube, you might have fact or dimension tables that have more data than you really are interested in. For example, in this lab, you might have a time dimension with decades worth of dates, but you're really only interested in the last 2 years. So all these dates here in this report that are circled in, or not circled, it's more of a square rectangle, in orange, you don't really want. We want to filter those out. Or maybe, you know, you can see here this retailer, Up the Creek retailer, doesn't have any fact data, so there's no use in showing that. It's kind of a waste of a row. So why don't we filter that out as well, so only show dimension values for those that do have fact data, and you know, as a result of that filtering, have a reduced time dimension as well as retailer dimensions, have something more tight. So your other options for filtering of your dimensions and fact tables in the past were to create a view, a database view, to do that filtering. But really, you know, doing this in the model is a lot easier and doesn't involve having to ask your DBA to create those views for you. Okay. And the last topic that we'll go through when we start going through the lab is estimating your hardware requirements. So new, coming in 10.2.2, you can use the hardware sizing calculator that's going to be available in Cognos Cube Designer, and you can use this to estimate the minimum hardware requirements to you know, get you that good, fast, snappy performance that you want and need from your dynamic cube. This calculator is based off of the information that's in the Developer Works articles that are out there. There's a link to those articles, to that article from the tool, so you can go from there, or just do a quick Google search for Dynamic Cubes hardware sizing. So really what this calculator gives you is a real quick kind of initial estimation of the hardware resources that are needed to, you know, to support your dynamic cube, and they're based off of some simple metrics here, based off of the number of dimension members, as well as the number of concurrent queries per report. And the cool thing about this calculator is that you can get the information from the underlying database that you're connected to. With a click of a button, you can say, you know what, I don't know how many members are in there, and I don't want to bother my DBA. I'll just click that button. It'll run those SQL queries, get that count of number of members, and populate that for you. Or if you do know, or you know, you might want to be planning for the future, you're like, I might go to 1 million members. What's that going to be like? You can type in those values yourself, and that calculate output shows you stuff like the required memory size, number of processor cores, as well as hard disk space for that cube. You then use the same information, this estimated values for the cube, for setting those corresponding Cognos and then query service properties, as well as the cube properties for the data cache, aggregate cache, and hard disk space out there. And we'll go through that in the lab. Okay? All right. Now for the hands-on part of it. Super fun. The Cognos Cube Designer open, and I have our model from last time. It has the recent sales and the historic sales cube, as well as the virtual cube for sales here. So first, let's get acquainted, reacquainted, as it were, with the model here. So let's click open this. All right, let's take a look at what's inside the historic sales cube. You'll see here the historic sales cube has 1, 2, 3, 4, 5 dimensions, order method, product, promotions, retailer, and time. And we'll look at recent sales, which has the same 5 dimensions here. Both cubes are pointing to the same underlying dimension definition here. You can tell by the little shortcut underneath each of the cubes. And okay, well let's enable a dimension for sharing. let's do it. Okay, so let's just double click on one of the dimensions, order method. It doesn't matter which one you click on. You can click on the shortcut here with the little shortcut icon there, or you can click on the dimension itself. But since my mouse is here, I'm going to click on order method. And then we're going to go down here to the bottom pane where the properties are, and you'll see a property called share member cache for all cubes. Let's click on that, and let's set it to true. That's it. That's all you need to do. So let's do the same thing for all the other dimensions. For product, let's share that. Promotions, let's share that. Retailer, share that. And time, I'll share that. Okay, so just to show you real quick, it is the same thing if I clicked on the shortcut or the main definition. They're all shared here. I'm just eyeballing on the right-hand side that the properties for the shared member cache for all cubes is true. Great. Okay, so let's start the cubes. All right, so let's start by let's start the historic sales cube. Let's go to publish here. I'm going to expand this publish dialog, and we're just going to select all the options. It's going to make it easy for me today. Select all the options. What it's going to do, it's going to add that cube to the dispatcher as well as to start the dynamic cube right here for us. So I'm clicking OK. And while that's working, what it's doing in the background is it's validating the cube, checking the metadata, publishing it out. Well, here, I'll take it back. Now it's fetching the metadata from the database, validating all those different pieces, and getting it ready for publishing to the content store. Well, you know what? Actually, it looks like I already have it there. You know what? Let's override it. Okay, so now it should be writing out to the content store. Now it's going to try starting the cube. Let's take note of how long we think it is. Great, that was pretty quick. All right, let's do the same thing for recent sales. We'll do a publish. Yep, let's select all the options. We're going to add it to the dispatcher, start the cube. Okay. All right, so that's going to go do its thing too. Oh, it's already published it. It's retrieving the cube status. And all right, that was really fast. I don't know if you saw that. It was working, and then the dialogues at starting cube, and almost instantaneously it said it's done. So let's verify that by going to the Cognos administration. Take a look at some of the metrics here. All right, so I have Cognos admin open here. And one thing I'll point out here on the left-hand side under the status tab, new for 10.2.2, the data stores tab is now called Dynamic Cubes. So that's a little name change, kind of cool. You see Dynamic Cubes right there, here, right there. It's kind of a one-stop shop for all things Dynamic Cubes related. So click on that. And since we have a few cubes out here, I'm going to change this to all server groups real quick. It's going to refresh the view. I'm going to go to default server group, query service, and it should list all the cubes under my query service. So I have historic sales as well as recent sales. Okay, so I'm going to click on historic sales, just highlight it here, and then on the right-hand side in the metrics pane, we'll see the metrics for the historic sales cube. So I'm going to look for, what am I looking for? I'm looking for the number of members in the member cache, and that is 4,056. And then I'm also going to look at the metric for last metadata load time. That took about 2 seconds. That was really pretty fast, not too bad. And so let's take a look at the recent sales cube metrics. And yes, it is the same number of members in the member cache, 4,056, and the last metadata load time is super fast, less than a second, like 0.041. So as you can see, the metadata load time for the historic sales cube is a little longer because it had to initially create all the dimensions and load its members into the memory cache first. And also, I mean, we started it first, but really it did all the heavy lifting and created the member cache objects first. And then when we started the recent sales cube, after that, it found all those dimensions and stuff in the memory cache already that it can share, and it just simply pointed to it. So instead of having to load its own copy of the members in its member cache, it just pointed to it, and this, as you can see, you get a lot faster cubes start, and then it did a load time for any of these cubes that do share dimensions. Now, this is kind of like, oh, okay, well, that's really fast. That saves me 2 seconds. But keep in mind, the cubes in this lab are very, very small. The memory cache itself is like less than 3 megs. So it's kind of tiny compared to the whole JVM here for the query service, which is set by the default as 1 gig. So it's kind of difficult to show kind of any drastic reduction in overall memory footprint in this lab environment. But I'm hoping you can imagine, though, that the impact of sharing very large dimensions, like your products with millions of members, or clients or customers, millions and millions, as opposed to a couple thousand, that you really do save in terms of like hundreds of megabytes or even tens of gigabytes across multiple cubes on your cube server. Okay, so that's pretty much it for now for this part of the lab. Later on, I will show you the hardware sizing calculator, and you can see, the estimated sizes for these member caches and really how much you can be saving by sharing your member caches. Okay, so that's that. Now I am going to switch back to the second task, which is, as you remember, dimension filters. Okay, so we're going to go to Cognos Cube Designer, and I'm going to actually open up a different model here. Nope, I don't know which. I am going to open up big time. So this cube is a cube that has a time dimension with lots and lots of dates here. So let me just quickly first publish this cube so you can see what the report looks like and stuff. Pay no mind to the name of the cube. It says filtered. It's not filtered yet. We will filter it, so we'll get to that shortly. But I just want to show you the kind of the before picture before we put it on a diet and filter out some of those dimensions and show you how fast and slim it is after that. Okay, so we're starting the cube. While that's going, choose the cube status. All right, starting the cube. Let's do it. I'm not sharing any dimensions here, so it's probably taking a little longer because I've loaded its own version of those members in the dimensions. All right, so I'm going to go into Cognos Connection. So I'm in Cognos Connection here. I have a bunch of reports. I'm going to go into the Dynamic Cubes lab and historic sales filtered, and I am going to run sales by Denver retailers by years. All right, let's run this report. And this is the same report that I showed you in the slides earlier. And as you can see, there are a bunch of years that we really don't care about. We really only care about the last 2 years, 2013 as well as 2014. And you can see here this row for Up the Creek, it has no values just yet. So let's filter those things out. Okay, so I'm going to go back. All right, back into Cube Designer. All right, so let's first filter the time hierarchy. But before we do that, I want to show you all the different members here in the member browser in Cube Designer. So over time, I'm open up the hierarchy, open up the member folders. I'm going to untwist all. You can see there's years from 1999 all the way to 2021. We don't need all that. That's way too much. Okay, so let's, I'm going to double click on the dimension, and it opened up the dimension editor for time. There's a new tab here. Well, it's not that new. It was new in Fixback 1. So click on the Filters tab here, and we're going to create a new filter. I'm going to click on this button, New Filter. I'm going to select that new filter. I'm going to rename it. I'm going to hit the F2 key, quick little shortcut to rename. I'm going to call it Last 2 Years. Okay? I have the last 2 years filter selected, and I'm going to go down here to my Properties tab, click on the Expression thing, and it's going to bring up the expression editor here at the top. So here we will specify a relational expression that will limit the number of rows for this dimension. So let's do that. We will first, so what did I say? I wanted the last 2 years, right? So I'm going to open up the years level, select the years, year attribute here, and I'm going to do, I want year between, and I'm going to use local timestamp thing. I want to extract the year from local timestamp -1 for last year, and I want to extract year local timestamp here. I think that's right. So let's click on Validate Syntax. Make sure I have all the right parentheses and all that. All right, great. Okay, so now with this expression, this filter expression will be added to any of that SQL that's used to load the members in the time dimension during Cube startup or even during member cache refresh. So with this filter expression, it will limit the time members to just the last 2 years. Okay, so what we can do here now, actually what I want to do also is I want to ensure that this setting, this property right here, excludes facts without corresponding dimension keys is set to true, so that the fact table is also filtered to those specific years that, those last 2 years. And this will ensure all our queries against the fact table will have that joined to the dimension table and have that filter expression we just specified up there. So as you might have remembered, our fact table does contain data from 2012, and if you don't select this, then you don't set this to true, then it actually will include it in any of the aggregation. So since we do have some extra data that we don't want, we'll make sure that this property is set to true. Okay, let's take a quick look here at our member browser. I'm going to do a refresh here. See that our expression taken hold? Yes, great. I just have my last 2 years here, 2013, 2014. That's all I want to see. Awesome. Okay. Okay, so now let's add that filter for the retailer dimension to only show rows that have fact data. So let's go to retailer dimension, double click on that. Click on the filters tab. I'm going to add a new filter. I'm going to select that filter, click on F2, little shortcut to rename. I'm going to call this Retailers with Sales. All right, select that thing down here, go down to the properties, click on the expression, and we are going to use a fact table filter here to filter dimension numbers. And to do that, we're going to use a hidden measure for that retailer site key and add that as an attribute to the table. So let me go here to the left-hand side. Do this one. Look at the tables. Under historic sales, that's my fact table. I have my retailer site key, a hidden measure first. So go back here. There we go. Retailer site key, I add it here. Select that retailer site key. Where did my mouse go? And I am going to set visible to false. All right. Setting visible to false, I'll show you here in the Project Explorer. It has a little different icon here that won't be shown in any of the studios or for reporting at all. It's a hidden measure. So we can end up using this later on when we create our expression. Okay, so that's grayed out. Let's go back to that retailer dimension. Now let's create that filter. I've already created it. Let's set the expression for that. And so let's grab that retailer site key, drag that over here, and make sure that equals out to the retailer dimension, retailer level, retailer site key. Here it is. Get in there. Okay. All right, so let's validate that syntax. Looks good. Again, with this filter expression, that little piece right here will be added to any SQL that will be used to load the members for the retailer dimension during Cube startup or member refresh. Okay, and so here too, that property for exclude facts without corresponding dimension keys is set to true. We can set this to false here, and that's because in our data model, because I know my data model, our data model has enforced referential integrity, so there's actually no dirty data here. So, and given the nature of this type of filter, that filters based off of what's connected with the fact, we don't necessarily have to have that here, and you can avoid having to have that join to the retailer dimension for all queries. Okay, so let's now publish this cube. Yes, let's overwrite it. Okay, that was fast. Let's go back to Cognos Connection and rerun that report. As you can see, it's been filtered. It only shows the last 2 years that I'm interested in, 2013, 2014, and it does not have that Up the Creek retailer that did not have any fact data. Okay, and click back, and I think that's all I wanted to show here for dimension filters. All right. Now for the last little bit here for reducing memory and stuff like that, let's go through the hardware sizing calculator that's new in Cognos Cube Designer. Again, this is new in 10.2.2. So let's do some estimates for these cubes that we've been working with so far. So let me reopen this model, the big time cube with all those, without any filters in there, that time dimension that's huge. And I'm going to right click on the cube. I'm going to select Estimate Hardware Requirements. This is a new action to bring up the hardware sizing calculator. Okay, so here it is. Note that this calculator, when it's first open, the focus is here in all users, and whatever input field you have focus in, the bottom pane down at the bottom shows you help information. So for users, it tells you what to actually enter here. Enter the total number of users to access the cube. Members, what does this mean? Enter the approximate number of members in the queue. Widgets, what does this mean? It's the number of queries in average report, as well as what are attributes. Okay, and as you can see down here in the bottom, underneath the estimated values, there are those links that I mentioned to you before about if you wanted to read, the details about how we came up with these hardware sizing estimates and the formulas and all that good stuff. You can click here on the Proven Practices document. That'll take you out to the Developer Works article. Okay, so since we launched this Estimate Hardware Requirements dialog off of the historic sales filtered cube, we can actually get the estimates based off the current cube model and the underlying connected data source that's connected here by clicking the Retrieve Values from Cube button. So I'm going to click that right here. Click that button, and what this will do is it'll run a bunch of level member count queries for each of the dimensions and auto-populate those two fields, one for members as well as attributes in this calculator for us. So as you can see, it went through a few of the dimensions already. Now it's on order method. It's going to continue running this. This is actually running a database query down to whatever the underlying connected database is. So it's doing the product dimension now. It can take a little bit of time. This is actually quite nice if you have your system connected to your development system or your QA system or any system that you may or may not know how many members or rows are in those tables. This makes it a lot easier and faster than asking your DBA to run those queries to find out how large these dimensions are. You can click that button and it'll run those queries straight away for you. Okay, so it's just still running. Now it's about retailer. I think it's almost done. So all right, time dimensions. I think that's the last one. I wasn't keeping count, but yep, that is great. All right, now you see it auto-populated the members here. There's about 10,906 members and about 3 attributes in the cube as it is modeled right now, connected to that underlying data source. And you can see the estimated values for a cube like this. If you were to have 100 users and 1 widget per workspace, you probably need about 38 megs for 4 cores. And here's the breakdown for each of the caches. So you see here that the member cache for that very large, big-time cube is 6 megs. Okay, so you know what? Now let's estimate the hardware sizing for that filtered cube, the smaller cube where we filtered out a bunch of stuff. So keep these in mind. About 10,000, let's say 11,000 members. That was about 6 megs. Okay. All right. So I'm going to close this. I'm going to open up a version of that model with the filters. So this is the filtered version. I saved it earlier. Just to double check it does have the filters. If it does, awesome. If I click Estimate Hardware Requirements, and click that button again. So like I said, clicking that button will run those SQL queries to the underlying data source. And now that I'm running it on a cube that has those dimension filters, it will use those dimension filter expressions as part of that SQL that it uses to get the size, the level count sizes and such. And I got an error. I'm not sure why, but let me try it again, see what happens. All right, I guess that was a momentary hiccup, and I think crossing my fingers and holding my breath did help here. Almost done. I think that's the last one. Yes. Okay. Great. As you can see here, it is only the filtered cube only had about 3,260 members, and only required about 2 megs for the member cache. So a lot less memory than the fully blown version of the cube if you do, filter your dimensions out for only those data points that you actually need here. Okay? So, but let's say you're connected to a data source that's, not actually representative of what's going to be in production. You're actually connected to something small for devs just to play around with things, but you want to see what it's going to be like when you go to production. So let's see. For the numbers, let's say we're going to go to 1 million. I'm going to type in 1 million. 1, 2, 3, 1, 2, 3. 1 million. As you can see, when I typed, the estimated values automatically updated down below here. So for 1 million members, 2 attributes, 100 users, 1 widget. You'll need about 1.6 gigs of memory with about 563 megabytes for the member cache. Let's change the attributes just to see. You'll see that the impact of changing, adding more attributes only just affects the member cache here, now 620. Okay, so really, I hope you can see the power and the benefit of using, the hardware sizing calculator here to kind of gauge the gauge the impact of any kind of model changes you might do, like adding additional hierarchy members or more attributes, or maybe you might open it up to more users, or change the concurrency in any of your reports. What the impact is to the hardware requirements. It's worth noting here that this calculator only estimates the hardware required for an individual specific dynamic cube. So if you have multiple cubes in your single server environment, or in your environment on a single server, you would need to kind of estimate the values for each of these cubes and then add them up, including your report server estimates. Okay, so that's that for the hardware sizing calculator. I'm going to leave this screen up for a little bit. I'm going to show you, just to connect two dots here, what these values correspond to in the Cognos administration portal. Okay, so let's, sorry. Okay, yeah. First, I will go to Query Service. Query Service settings, and down here for the initial JVM heap for the query service and JVM heap size for the query service, this is the total memory required for your query service to hold all your cubes. Right now it's set to 1 gig, which is a lot more than you need for any of these cubes. But so just as a pointer, this is where you would set that limit for your entire query service. And as a reminder, let's take a look at the cube configurations. There are a few ways to get to the cube configurations. Since we already have this panel open here with the query service settings, I'll show you one way and I'll show you another way in a little bit. So from here in the query service, you have the dynamic cube configurations. Let's click on Edit. And in the screen, it shows you all the cubes that are deployed to this query service. We'll click on the pencil for, let's say, the historic sales cube. And you'll see, excuse me, the data cache size limit here, the amount of maximum amount of disk space to use for result set cache, maximum space for in-memory aggregates in megabytes. Okay, so you can see here the corresponding nature of aggregate cache, the aggregate cache limit here, data cache, as well as disk space for your result set cache. Note that there is no corresponding cube configuration setting for things like CPU or member cache or temporary query space. That's just something you need to factor into your total query service JVM. Okay, so I want to cancel that. That's how you get to the cube configurations from the query service settings. You can also get to those same settings from a cube here on the cube, set properties, same cube properties here. Okay, let's move on to the second lab module. And after the second lab module, maybe we'll take a quick bio break. Okay, all right. So we just took a look at reducing memory footprint and building an efficient cube. Now we're going to look at maximizing reuse and simplifying report authoring. Now there are two parts to this. We're going to talk about relative time as well as named sets. So first, with relative time, if you enable your cube for relative time, you can author a bunch of your reports relative to a current period. And you can run these reports at any time, and they remain valid because of the value of the current period expression, and it's evaluated at execution time. As you probably saw from last year's lab, and maybe you're already familiar with, to use relative time, you define a dimension as a time dimension, and then you update and modify a bunch of the time properties for the levels to generate relative time members for that hierarchy. And a bunch of the predefined relative time members are things like current period, current period to date, prior period to date, current period date change, prior period date to date change, current period growth, and all that stuff. And it's really easy to then just go into your studios and use these predefined relative time numbers in your reports by simply dragging them into any report. As part of modeling your relative time dimension, each level has a current period property, and the current period property of a level is used to filter the members by the level key to find that single leaf member that represents your current period member in that hierarchy. There's different ways of expressing that current period expression. It could be static. Just type it in like it's going to be 2014 September 30th or whatever. Or you can base it off of some database expression for current date and time, as we did last year. Or it could be based off of a relational database value that's populated during the ETL process. And that's what we'll do here in the lab today, as I'll show you how to use that this method of specifying the current period property, the best practice for that. But new in 10.2.1 Fixed Pack 3, we've added a bunch of extensions to the relative time functionality, including support for members that correspond to future time periods. Here you can see them, identify them in the tree. So for next month to date, next, whatever things, future periods. Single period custom members, something like, for example, same month prior year. Period to date custom members, as well as end period running total members. Those are some of the new relative time extensions that we've added in Fixed Pack 3, 10.2.1 Fixed Pack 3. And we'll also have the ability to control what relative time numbers you can add to a time hierarchy, and we'll go through that when we go through the lab. I'll show you how that looks. New in 10.2.1 Fixed Pack 3, we also added support for name sets we can define in the cube model. Basically, a name set allows you to create an expression that defines a set of members. You can then, when you go to run a report or create a report with that name set, that corresponding expression is evaluated at runtime, and those members are rendered in that report. So you can find these name sets in the studios in the metadata tree under a name sets folder, and you can do things like create a dimensional expression for things like top count, or top 5 customers by sales or something like that. All these name sets are dynamic, which means they're evaluated at report execution time, and they are evaluated within the query context and the security of the current user. So, for example, if you had a name set that was nested on an edge under a set of years, it will be evaluated independently for each year. So you can find out for each year who are my top 5 customers by sales. So really, you can probably see the advantage really of using these name sets is that you can define them once in your model and use them over and over again in your reports. Okay, and so in the lab, which I'll show you in a little bit, we're going to create a name set for the top 5 product lines by sales. All right, let's get hands-on. I'm going to open up Initial Modeling Cube, the starting point. And this is the starting point of a historic sales cube. It's nothing special in it. It's just the basic cube. So, see, we have the time dimension here. You'll see the little time icon, and to kind of signify it as a time dimension. So you see that little badge in the corner. You can also see here on the right-hand side of the properties pane for the time dimension. Dimension type is time. So let me open up that, double-click on the time hierarchy. You'll see for the hierarchy properties, you'll see that add relative time numbers, the property is true. Okay, so let's take a look at the levels that are in here. Just getting reacquainted with what we have modeled here. So for the levels for the time dimension, we have year. You'll see the level type here is years. Quarter, level type is quarters. Month, months. Day is days, schnozberries are schnozberries. It's all there. Okay. One thing that I'll want to call out here, new for 10.2.1 FixPack 3, we have a few new level types that we're supporting, and they are holiday, where is that? Holidays, seasons, semester, as in like an academic semester, which basically is like a half of a time period, and trimester, which is kind of popular here in the U.S. and Canada for as academic trimesters, or anything that's really a third of the period. Okay, so those are some new level types for relative time support that we've added in 10.2.1 FixPack 3. Okay. Okay, so now that we have the day level selected, you'll see here that the current period expression that we had from last year used the local timestamp expression, and we pretty much extracted out certain bits to find that current day. Let's change that. So let's try to use a single row, single column table that we populate during ETL instead. The reason why you might want to do something like that is because even with this expression right here, it is the local timestamp expression in this current period expression is evaluated at cube startup time, and so maybe you want to do reporting and stuff on your cube where current period isn't exactly quote unquote now or when the local timestamp function was run. So you actually have more control over what your current period can be by populating this single column, single row table during your ETL cycle. So let's take a quick look at what this table might look like. So here, DC sales table, current period is my table. It's simple. It's just like that. Let's view data, take a quick look at it. This is a single row, single column table. I'm calling it current period. You can call it whatever you want. With a column for the day key, it has to correspond to the lowest level of your date or time dimension. In this case, it's day. And let's, for the sake of argument, let's say we're going to flash forward, time traveled a little bit. Current day is actually 2014, October 21st. Let's pretend that's the current day, or at least that's the current day that we want to start reports to base off of. Okay, so that's there. So let's change some things. So let's double click on the day level, and let's add this add this column as an attribute here. Okay, drag and drop there, and I am going to use that same trick I showed you earlier about making this a hidden or not visible property. So select current day key, go down here to properties, visible. I'm going to set that to false, so that's not visible. Just double check here. Day. You can see that the icon's a little different, a little grayed out to show that it's hidden. You don't see it. It's not there. Well, it is there, but it's hidden. So let's now go to the go back to that current period expression. Let's get rid of all this stuff, and let's just drag in that current day key. That's it. That's all we need to do. What this will do is it'll just look up that column, get that value. That's the current period. But you might notice we now have an error. So let's fix that. Let's join that current period table to the time dimension and fix that up. Okay, let's double click there. I'm going to go to the implementation tab here. There's no join just yet. Let's add that join here. Okay, we want to go from current period, We want just going to be simple one-to-one and add column, day key, current day key. Perfect. Okay. And that's it. Error went away. Great. Okay. That's all you need to do for setting your current period expression to point to that current period table in your database. Now let's take a look at some of those relative time extensions that I mentioned earlier that were new, that we added in 10.2.1 Fix Pack 3. Okay, let's see here. Let's first take a look at the member browser. Time dimension, time hierarchy, members, all. Okay, all, you'll see the current, the relative time numbers here. You have current year. Under current year, you have things like its quarters, Q1 to Q4, as well as current quarter, and so forth. But now, as I mentioned earlier, you now have the ability to control what relative time numbers are shown here in this, well, not just here, but shown in your time hierarchy, whether it be here in the member browser or in the studios, the metadata tree in your studios. So I'm going to double click on the time hierarchy. There's a relative time tab. I'm going to select that, and you'll see there's some new auto generation options right here that you can control. So you have control over what prior periods and periods to date you might want to show. By default, auto generate numbers is selected. Let's just keep it. I want to see those prior periods and such. Let's see, the next option here is for next period, the next periods to date. By default, it's not selected, but I want to see them. So let's see what happens when you want to see them. So let's select auto generate numbers there. Reference relative time numbers in the subtree. By default, it's include. Let's just see what exclude does. We'll do that. All right. So let's see what the effect of these changes are to our member tree. So let's collect that. I'm going to do a refresh of that member browser folder here in the Cube Designer. Open that up. Open up all. You'll still see current years there. As you can see here, it doesn't actually show the quarters underneath it anymore, and that's because we chose to exclude any references to relative time numbers in that subtree. Okay, so I don't think I can show you next periods right here, right now, but I will show you that later on in the lab when I open up the studios. Okay, so but for now, let's switch gears a little bit. I'm going to show you some of those new relative time extensions. And those are, you can define those here at the bottom half of the relative time the tab panel. And on the right-hand side are a few shortcut buttons for creating new objects. So the first one on the top here, we're going to create a new single period definition. Okay, I'm going to select that. I'm going to go down to the properties section. I'm going to call this, let's do same month, prior year. And so for a custom single period, like for example here, same month, prior year, basically what we're going to be setting are different things like the target period, its offset, and as well as the context period. So since we said this is same month, we're going to select month. It's the same one, so 0. And last year, so the context is year, but last year, so we're going to do -1 for last year. So that's that there. So let's take a look real quick here in the member browser what that did. So let's do that refresh here. Open up members. Open up all. Open up current year. And open up current quarter. And you'll see it right here. Under current quarter, same month, prior year. And it's under quarter because our target is month. Because if you want to show months, it's the same month, prior year. It'll be under quarters. Okay? So let's create another custom period. The second one that we've added support for is custom period to date. So I'm going to click on the second shortcut here, custom period to date. I'm going to go down to the properties. I want to give it a different name. Let's do something like quarter to date, prior year. Quarter to date. We'll, change the to date period to quarter, change the target period to month, because we want the quarter to date, and the month is the periods underneath quarter. For context period, we'll keep it at year, and for the context period offset, we'll change it to -1. Okay, so those should be the settings for quarter to date, prior year. That's because we want quarter to date. Month is the target within quarter last year, so it's -1 year there. Okay, let's do a refresh in our member tree, see where that lands us. Expand all. This is a to-date function, so we're going to look under year to date. And here it is, quarter to date, prior year. That's the one we just added. All right, let's create another one. Last one, the custom end period running total. Let's do something like 6-month rolling window. So let's do that. Let's call this 6-month rolling window. All right, 6-month rolling window. It's pretty straightforward. Number of periods, 6 of them. What's the period? What's the target period? Month. We want 6 months. Offset is 0 because we want to include the current month. And context period, we'll leave it year because we want it for this year, and 0. So 6-month rolling window for this year, including this year, including this month. Pardon me. So 6 months, 0, year, 0. Let's take a quick look at what that looks like in the member browser. Do a refresh. Down here, expand all, and it is down here, 6-month rolling window. Awesome. All right, let's publish this cube and take a look at it in the studios. Do publish. Yep. So we started our cube. Let's go into Cognos connection. We'll go into the labs folder. Let's take a look at our relative time reports here. Let's run 2 reports. We'll run one report with the relative time definition, just comparing, basically showing the answers you will get when you create a crosstab manually, getting all the dates you might need, as well as a simple report using those relative time numbers. And so you can see here you get the same answers. So for example, for rolling 6-month window, it's about 19 million, blah, blah, blah. And all I did was drag and drop that 6-month rolling window custom relative time number into the report. Or you can manually create it, dragging and dropping each of the last 6 months. Remember our current period was October 21st, 2014. Adding them up, it is the same number, the same answer. Similar here for same month, prior year, drag and drop the relative time custom number, or specifically find last year, October 2013, same number there. And here, last one there. Same thing. So let me go back real quick. Let's open this up in Report Studio so we can take a look at that metadata tree that I promised you, that you'd see those future periods, those next month, the next things. And so, when we published that cube, I don't know if you noticed, but I did restart the cube. So what it did is it took that current period expression, looked it up, since it is pointing to that current period column in that table, used that value as its current period. So current period is October 21st, 2014. So let's expand that time dimension, time hierarchy, take a look at the numbers, close that. You'll see here, you have the current year stuff, current year. If it doesn't show the quarters, remember we excluded the reference numbers. Expand current quarter. Here's my custom number here. Remember, here's our year to date. We have our quarter to date here, rolling 6-month window. Under current quarter, you'll see here the next month future period relative time number, as well as, let's see, I'll show you some more here. Under quarter to date, there's a few more future period relative time numbers here. Okay, so that's a quick little overview, show and tell of the relative time extensions that we've added in 10.2.1 FixPack 3. I will go back now to Cube Designer and we'll go through some name sets, or creating a name set. All right, so let me open up model. I'm going to open up relative time extension here. I want to expand that cube here. You'll see there's a folder here for named sets. I'm going to do right click on that. I'm going to do new. You can organize your name sets in any way you want. You can create a folder, you can create sets, you can nest them however you want. But for now, we're just going to create one name set here, and I'm going to call it top 5 product line by sales, because that's what I want. And I'm going to double click on that, top 5 product lines by sales, and double clicking on that brings up our expression editor on the right hand side. Since this is a little different, it's a multi-dimensional expression editor, so really only dimensional functions are supported here, so it's not relational ones, it's just the multi-dimensional ones. So that's there. If you need any help with if you need help saying it, but if you need help with your multi-dimensional expressions, there is a little bit of help here within the Project Explorer section. At the bottom, there's an f of x or a functions tab. Click on that, and it'll bring up some help text for you that you can use when you're working with the expression editor. So, for example, you might want to open up dimensional expressions, stuff under R to Z. Maybe you want to look at top count to refresh your memory. What's the syntax for top count, and what does that do? So you can see here, top count here. All right, okay, now I remember how to use it. I can just drag and drop. I want to use top count here. I'm going to open up the parentheses, and I'm going to give it a set expression and all that good stuff. I'm going to switch back to the package view. So instead of clicking on, we click on the f of x, the functions tab here. Click on the package, go back to the Project Explorer to see our cube stuff. Let's go to the product dimension, and let's open up the product classification hierarchy, and let's say the product line, because we want top 5 product lines. I'm going to drag that over here. I want top 5. I want to base it off of sales, so let's get my measure dimension, historic sales. I want to base that off of sale total, so I'm going to drag and drop, put that there. Close that parenthesis, check my syntax, all looks good. Just a reminder, the validation here in Cube Designer is a syntax only. Validation is not semantic or anything like that. Semantic checking is done at Cube startup time, and if there's any errors or things that it sees during Cube startup time, the expression will not be validated and removed from the cube, and you can see those errors in your log, in the log files. Okay. All right. So that's that expression: top count, product line 5, top 5 sales. That's that. Let's publish this. Okay. Publish. Okay, that's all. Publishing. Yes, let's replace it. I like this one instead. And we're almost done, guys. Getting ready for that break. All right, the cube's restarted, and let's go back into our Cognos connection, and we have that other report that I want to run, top product line using named sets. And again, this is one of these reports where I have a little side-by-side of using a name set, dragging and dropping that name set that was defined in the report versus creating a query data item on the right-hand side. So you should see here in the top here, I just dragged and dropped the top 5 product lines by sales using the name sets. You can see they're actually ordered here and sorted from greatest to least. And it actually is the same values as if I were to drag and drop just all product lines. This is not sorted or anything, or any top or anything like that. It's just all product lines. You can just double check your answers. Are they still the same? Nothing's changed except the order, and it did order them that way. The bottom side-by-side crosstab here shows on the left-hand side creating a report for Las Vegas 2014 quarter 1. For each quarter, I dragged in the name set. So for each quarter, it evaluated in its context what are my top product lines. So you can see for quarter 1, 2014 in Las Vegas, number 1 selling product line was camping equipment. Quarter 2's product personal accessories, and then back to quarter 3, camping equipment won out again. Same on the right-hand side. We can do the same thing with the query report query data item, but as I mentioned before, especially with name sets and relative time and all that stuff, the real advantage of doing this modeling in your cube in the model is that you can use them over and over again. You can author them once and reuse them in multiple reports. Okay, and I think that's all I wanted to show here for name sets, as well as what I wanted to show for this lab section of maximizing reuse and simplifying report authoring. So I'm going to pause for a moment. Any questions on this lab section so far?
Can I drive current day, that as a parameter from a report in BI?
No. So current day is determined at cube startup time. So it's something that has to be part of the cube model and as part of that current period expression that you defined in your cube model. So you can do it one of 3 ways. Like I mentioned, you give the static value, so you can type in your model what that current day is. You can use an expression to get the current time, for example, using a local timestamp like we did last year, or you can do what I just showed here today, which is getting that value from a database table that you populate during your ETL. So yeah, no, the answer is no. That's doing something as a parameter in at report time is a little later. So you can't affect relative time in the model with something that you define in your report.
Thank you.